Our story begins in January of 1610, when the great Italian astronomer Galileo Galilei first peered through his telescope and discovered 4 moons orbiting Jupiter. Among them was Io, along with Europa, Ganymede, and Callisto, now known as the Galilean moons. Named after figures from Roman mythology, Io was named after a priestess of Hera who became one of Zeus's many lovers. In mythology, Io was transformed into a cow to hide her from the jealous Hera. The name suits this fiery moon which, like its mythological namesake, is closely tied to Jupiter. Io is roughly the same size as Earth's moon, but the similarities end there. Io's surface is unlike anything we see on Earth or any other body in the solar system. It's dotted with over 400 active volcanoes, rivers of lava, and large sulfur plains, making it the most geologically active object in the solar system. At Io's heart lies a dense iron or iron sulfide core surrounded by a mantle made of silicate rock. Above this lies a thin crust composed mostly of sulfur and sulfur dioxide. The constant volcanic activity on Io is powered by the immense tidal forces exerted by Jupiter's gravity, which flex and squeeze the moon's interior, generating heat. Unlike Earth's moon, Io has virtually no impact craters. This is because its surface is constantly being resurfaced by volcanic eruptions. It's estimated that Io's surface is completely renewed every million years or so, erasing any traces of ancient impacts. Volcanism is the defining feature of Io. The moon is home to some of the most powerful volcanic eruptions in the solar system. These eruptions are so intense that they can be seen from Earth using large telescopes. But what exactly causes this extreme volcanic activity? Io's intense volcanism is driven by tidal heating. As Io orbits Jupiter, the planet's immense gravitational pull causes Io's shape to deform, stretching and compressing the moon's interior. This constant flexing generates significant internal friction, which in turn creates immense heat. The result? Molten rock or magma that seeks an escape through the surface. One of the most famous volcanic features on Io is Loki Patera, a giant lava lake that spans over 200 kilometers in diameter. Loki is the most powerful volcano on Io, erupting regularly with a power output greater than all of Earth's volcanoes combined. Another notable volcano is Pele, named after the Hawaiian goddess of fire. Pele's eruptions create massive plumes that can reach heights of up to 500 kilometers, ejecting sulfur and sulfur dioxide into space. The volcanic eruptions on Io are not just spectacular, they also play a crucial role in shaping the moon's surface. The lava flows from these eruptions can stretch for hundreds of kilometers, reshaping the landscape with every outburst. The vibrant colors seen on Io's surface, yellows, reds, and blacks, are due to various forms of sulfur and silicate materials deposited by volcanic activity. Given Io's volcanic activity, you might expect it to have a thick atmosphere. However, Io's atmosphere is extremely thin and tenuous, composed mostly of sulfur dioxide. The atmospheric pressure on Io is less than a billionth of Earth's, making it essentially a vacuum. Despite its thinness, Io's atmosphere is constantly being replenished by volcanic eruptions. However, because of Io's low gravity and the intense radiation from Jupiter's magnetosphere, much of this atmosphere is stripped away and lost to space. Some of the atmospheric particles are ionized and form a plasma torus around Jupiter, contributing to the planet's powerful auroras. Interestingly, Io's atmosphere undergoes drastic changes when the moon passes into Jupiter's shadow. During these eclipses, temperatures on Io's surface plummet, causing the sulfur dioxide in the atmosphere to freeze out and settle onto the surface as frost. When Io reemerges into sunlight, the frost sublimates back into gas and the thin atmosphere is reestablished. Our understanding of Io has been greatly enhanced by several spacecraft missions, each bringing us closer to this volcanic world. The first spacecraft to visit Io was Pioneer 10 in 1973, followed by Pioneer 11 a year later. These missions provided the first close-up images of Io, revealing its unusual surface colors and lack of impact craters. However, it wasn't until the Voyager missions in 1979 that we truly began to grasp the extent of Io's volcanic activity. Voyager 1 captured the first images of active volcanic plumes on Io, shocking scientists who had never expected such intense geological activity on a moon. The Galileo spacecraft, which orbited Jupiter from 1995 to 2003, provided even more detailed observations. Galileo made several close flybys of Io, allowing scientists to study its volcanoes, lava flows, and interaction with Jupiter's magnetosphere in unprecedented detail. Io is full of surprises, and there are many fascinating facts about this fiery moon. For example, did you know that Io has mountains taller than Mount Everest? These mountains, formed by the uplift of Io's crust due to volcanic activity, can reach heights of up to 17 kilometers.